Hey, hi everyone. Welcome back to Data Engineering Talk. We will continue our talk on big data. So, we have learned in the last video, we have learned what is big data, why we need big data, and what all the V's which are necessary, what all the things it covers. So, we have covered most of the things in the big data. So, we will cover here because the thing is like I'm planning to start a PySpark, uh, but the thing is like before jumping directly to PySpark, we should know few of the things which I will try my best to cover in this video. Then we will move towards PySpark because that is the most important thing in a data engineering interview and the work which you will be doing as a data engineer. And the most questions they ask in PySpark is about coding, the conceptual thing, the optimization thing, everything, whatever they can ask in the real time scenario. So we'll try to keep this particular video, like before starting PySpark, we will try to keep and talk about all the necessary concepts which is needed to know like why we actually need PySpark. So let's start. Is my notepad, yeah, here? So we have covered these. That's okay. So let's start with why big data needs a new technology. So that is actually the further concept actually be, on the basis of these questions only. So I will try to frame a scenario and the answer is there. Uh, just imagine you are trying to store and process an ocean of data with just a bucket. What will happen? So you can't store that, right? So that's what happens whenever we use old systems to handle big data. And because the traditional system, whatever was designed, so that are actually never designed for this kind of scale. So to understand what all technology we need, let's break it down step by step. So to move further, we need to understand few of the concept, that is monolithic versus distributed system. Distributed, yeah. We need to understand these two concepts. First one is monolithic and second one is distributed system. So let's first try to understand what is the monolithic systems. So monolithic systems are actually kind of you can think in that way, like think of a big and powerful computer. This is actually, you can think it of like it is actually a big and powerful computer, and it has its own resources. It has its resources. And what resources it have? Let's say it has CPU, it has memory, it has storage. Okay. And CPU, let's say the CPU, they have four cores. And memory, let's say they have 8 GB RAM. And in the storage part, let's assume like the storage is actually 1 TB, 1 TB of hard disk drive, SDD. So to understand this, we need to understand the further thing, that is actually, now if you want to double these resources, so you, the resources which you have for this particular computer is actually 4 core CPU, 8 GB RAM, and 1 TB hard disk. So if you double these resources, suppose like you want to double the resources, and double in the sense like you want the CPU core to be 8 core, memory you want it as 16 GB, and instead of 1 TB you want it as 2 TB. Okay, that's what you want. That's what means doubling the resources is. So what happens if you double the resources? If you double the resources, what will happen? You might be thinking, if you are doubling the resources, your performance should also double, right? You expect the double performance, right? You means you expect double performance, right? Yeah. But here the catch is like this is not going to happen. So but the reality is different. Means reality is different means it doesn't matter how much like you are adding to the resources, the performance doesn't grow proportionally. Yeah, because at certain point it won't grow. Suppose this is your resources, this is your resources, and this is your performance, right? And you are keep on increasing the resources, you are expecting that the performance should also grow, but this won't grow. That's what this is a concept. This is the concept of vertical scaling. Vertical scaling. So this is called vertical scaling, and it has limitations. Yes, you heard it right. It has limitation. It cannot go. The traditional way you are thinking, I will increase the resources and my system will be fast, performance will increase. No, it cannot. That's why monolithic systems are not scalable. That's why monolithic systems are not scalable. That's why. So we have learned about monolithic systems. Let's move forward to distributed systems. Distributed systems. So in what we have seen in monolithic, like we have one super machine, and that is having the resources and all, right? So here in distributed system, what will happen? Instead of one super machine, imagine like you have a team of machine that is actually nodes that are actually working together. So in technical term we call it as nodes. So here let's note down the what are the key concept, so that it will be easy for you to, whenever you are going through the video, it will be easy for you to click on the mind, like okay, in the distributed system we have these things. So what will happen? Instead of one super machine, one super machine, what we will have? We will have a team of nodes, or like team of machines or nodes. In technical term we call it as nodes. And these all team of node that are actually working together, working working together. Yeah, these all are working together. And let's take an example. Suppose we have a cluster of 5 systems. Cluster of 5, cluster of 5 systems. So in the cluster of 5 system, let's assume each having 4 core, and it will be each will be having 8 GB of RAM. Also, let's assume the storage is 1 TB. Okay, so the combined resources would be 20 cores. Okay, 40 GB RAM and 5 TB storage. Yeah, 5 TB storage. So if you want, here the concept is, if you want more power, you just add more nodes. That was actually the limitation of monolithic, but here you don't have the limitation. Just try to understand the concept which I told you in the monolithic. That is just opposite of uh, distributed systems. So what happened if, let me make you start a star, if you want more power, Then what you need to do? You need to just add more nodes. More more node. So if you want to increase the power, you just need to add more node. This concept is actually known as horizontal scaling. Horizontal scaling. Remember, you in monolithic we are thinking like we will increase the resources and performance will increase, but it doesn't happen. That was vertical scaling. Here we are increasing to increase. If we want more power, we need to increase more nodes, and it can happen. And that concept is known as horizontal scaling. So the best part is here, doubling the resources, double the performance. That is actually true scalability. Whenever we are talking about the scalability, na, that's why we prefer distributed systems. So it is having true true scalability. That's why big data systems distributed architecture, not monolithic. Big big data system uses distributed architecture, not monolithic. Not monolithic. They use distributed architecture. Okay. So that was about the difference between monolithic and distributed. So in the interview question, people can ask like why big data uses distributed architecture. So I have explained you very well. What I explained you, there is a difference between vertical scaling and horizontal scaling. You just have to show them, and I'm damn sure the interviewer will be impressed. Yeah. So that was about distributed systems, and now there is a question comes up like what makes a good big data system. Good big data, yeah, what makes a good data system? So while designing the big data system, we need to think about three things. First one is storage. Second one is processing or computation. Third one is scalability. Yeah. So what will happen in storage? We need to see where will huge data can be stored. Here in storage, where will the huge data can be stored? The answer is distributed storage, right? You might be relating with the distributed system. Yeah, that's correct. The storage, the huge data will be stored in distributed storage. Again, just try to think in that way. How will huge data can be processed? In what manner? Distributed manner. That is, distributed processing will come. Yeah. Again, just think about it. Can the system handle the growth in scalability part? Can the system handle the growth? Yes, because distributed systems support horizontal scaling. Can system handle growth? Yes. Why yes? Because distributed systems support horizontal scaling. Horizontal scaling. Yeah, I have tried to cover from very basic to the advanced, not advanced, not a rocket science, but the core concept of distributed systems and monolithic system. And what all things we need to make a good big data system. You heard it right, distributed system. Yeah, so after like learning distributed system and monolithic system, there is another concept that comes up. We need to learn that part as well before moving and jumping to PySpark. That is actually very important, and we need to learn that. That is Hadoop. Here we need to understand this concept very well. Then only it will be easy for us to understand why we need PySpark, why we need Spark, why not everything can be handled with Hadoop. Yeah, that is the thing. We need to understand it. Okay, so we will now cover Hadoop part. So Hadoop part, it is actually kind of in Hadoop comes as the hero of big data in the early days. Early days means there that was the only technology that time was available to handle the big data. That time it was very kind of we used to worship that tool. That, oh, Hadoop can handle big data technology. Oh my god, it is a very powerful tool. So Hadoop is actually Hadoop. That time, Hadoop was the first framework that was actually designed to solve the big data problems. And it is a framework because it is not just a single tool. But it is actually a kind of combination of different tools, different tools just to solve the big data problems. So it's a framework. It's a combination or ecosystem of several tools. Why? To solve the big data problem. Yeah, to solve the big data problem. Yeah, that was just what is Hadoop. There are things like before PySpark, people were using completely Hadoop. Yeah, that I will tell you like why we have actually moved to PySpark. Let's see like the evolution of Hadoop first. So in Hadoop was actually we had Hadoop 1.0 in 2007. 1.0 in 2007 we had Hadoop 1.0, and the next version comes up in 2012, and now we are using current version, we are using Hadoop 3.0. In 2012 we have Hadoop 2.0, and current version is 3.0. This is just an evolution, like what version we were using. Now yeah, company still few of the companies uses Hadoop. But the thing is we will understand after this concept, the core concept of Hadoop. You will know like why we have moved to Spark, why we have moved to PySpark, sorry, Apache Spark or PySpark. Yeah, so the concept, there are actually three core component of Hadoop. It is having three core component. What all component? HDFS. SDFS. What is SDFS? Yeah, SDFS means Hadoop Distributed File System. Hadoop Distributed File File System. This SDFS is actually kind of distributed storage where the data spans across multiple systems. Yeah. Now another component is MapReduce. Yeah, this is MapReduce. This is actually kind of that was used for distributed processing. MapReduce was used for distributed processing Since the data is stored across multiple nodes, the conventional programming like model cannot like process such data. Therefore, MapReduce was there to process the stored the data that was actually stored using distributed storage. Yes. So that was the work of MapReduce. Then another thing, next component was Yarn. Yarn. Yeah. Yarn is actually a kind of resource manager that negotiate for the resources to allocate for the processes. This is actually responsible for allocating. This is actually responsible for allocating the processes to the nodes. Yes, it is actually a resource manager. Resource manager. And what is MapReduce? It is actually a distributed processing. Distributed distributed processing. Yes, these are actually the core component of the core component of Hadoop. So let's again recall it. Suppose suppose we this is Hadoop. Yeah. So what all thing we have? We have one. Yeah. What thing we have? We have HDFS. HDFS. Hadoop distributed file system. Another thing what we have? MapReduce. Next thing what we have? Yarn. Okay. Let's understand what it is. Why? What it is for? Why? Hadoop distributed file system is for distributed storage. Understood? It is used for storage. And MapReduce was used for distributed processing. You need to remember this keyword. Then only you will be able to understand this. Distributed processing. And Yarn is actually kind of resource manager. Sorry, one second. Resource manager. So now I will tell you like what happened to MapReduce. What happened actually? So what happened? Writing MapReduce code was actually very hard. That time it was very hard because it was involving Java to code, which was actually requiring many line of code even to perform a small task. Therefore, MapReduce was actually kind of that time it was absolute at the moment, and there are other alternatives that makes those things very easier. And we were moving instead of using MapReduce. Yeah. So MapReduce code was actually in Java. Yeah. So these were the things what it was using and what it was there. And I will tell you one more thing. Like I will try to cover. These were the core component. These were the core component. This is the core component. Okay. There are few more things available. This is the core component, and there are the ecosystem technologies as well for Hadoop. What all technologies? Let me try to understand. I guess I'm going right. Let's see. Yeah. What all technologies? This treat it treat it as core components. This treat this as core component. Okay. What all things we have? We have Hive. In the ecosystem tools, we have Hive. We have what we have? Sqoop. I will tell you for what purpose these are. Other we have pig. Next one what we have HBase. We have Oozie. These are the things. So even apart from the core component of the Hadoop, the ecosystem technologies came into picture to make the thing easier for processing. Yes. So I told you about the I told you about the core component ecosystem, and even I told you the challenges with MapReduce. Writing code in Java was hard. Even a small task required 100 line of code, and it was very slow. Because of this, MapReduce became obsolete over time. Yes, these were the challenges with MapReduce. And Hadoop ecosystem tools, as I mentioned here, these are the Hadoop ecosystem tool: Hive, Sqoop, sorry, Sqoop, Oozie, Pig, HBase. Let me tell you for what purpose these all tools are in the ecosystem. We have Sqoop. Sqoop was to move data between databases and HDFS. Okay, we had the cloud alternative as well for like Azure Data Factory we use. The cloud alternative for this is Azure Data Factory. So in ADF we used to move data from one place to another, and here as well. Here we move data between databases and HDFS. Next we have Pig. Pig was Pig was kind of scripting language to clean the data. It was scripting language to clean the data. And next one we have Hive. Hive was actually Hive is actually kind of SQL like interface to query the data. Yes, it is SQL like interface. When you want to query the data, you can use that. Next one what we have is HBase. HBase is actually kind of NoSQL database for quick lookup. If you want the quick lookup in the NoSQL database, you can go for uh, this is just like that, HBase. And we have, if you want to understand in some other way, the cloud alternative, you can think of just like for Sqoop we have ADF. For this we have Cosmos DB. So just think this way. Let me clear you. Let me clear you so that you can just understand the, you can just remember the basic keywords. Sqoop. Sqoop is for data movement. Data Data movement. Pig. Pig is for data cleaning. What we have? We have Hive. Hive provides you what? SQL like interface to query the data. SQL queries. Next one is Oozie. It is actually workflow scheduling. Yeah, workflow scheduling. What we have next is HBase. Fast access NoSQL. Fast access no SQL. This is all about Hadoop ecosystem. This is all about Hadoop ecosystem. Yes. So you might be thinking now, what is the current status? What is the current status of Hadoop? So think it that way. Hadoop was the ecosystem tool that started the revolution. This Hadoop started big data era, and then HDFS and yarn are still being used, but MapReduce is actually kind of obsolete. We are not using because of the lengthy code, and it is very hectic to write the code. Just think about the developer who were writing code at that time. Yeah, and ecosystem tools kind of made it was Hadoop. Those ecosystem this ecosystem tool, this ecosystem tool made Hadoop very powerful. But the thing was, it became very complex. You had to learn too many different tools. That was the reason, like, we were kind of like, we that time the developers got messed up their mind, because they had to learn different tool for different purpose, for different thing. It was too hectic. Yeah, so this was all about the Hadoop ecosystem and all. So let's summarize this, whatever we have learned. Summary summary is, we have learned about monolithic versus distributed. We have learned about distributed systems that actually solves with the horizontal scaling. This actually fail at big data because of vertical scaling. This actually handles with the horizontal scaling. And we have learned Hadoop introduced just to the world for handling the big data stuff using HDFS, MapReduce, and Yarn. Ecosystem tools made easier, but MapReduce slowed things down. That's why industry moved to better alternative. Yes, that's why industry has moved now from Hadoop to Spark, Hadoop to ADF, or any other cloud native tools. You heard it right. So the new need of this new technology stack in big data came from a simple truth. Old systems were built for buckets of data, but today we deal with the oceans of data. And only distributed or scalable systems like Hadoop, now we are working with Spark and cloud platform, can handle the ocean efficiently. We cannot handle with the traditional things. Yeah, so next, we have learned most of the things. I hope you people have enjoyed it. Now we will move forward to learn the main thing which I was waiting for. I won't be like going deep and deep dive to learn and to let you know about how to write map reduce code. That's of no use. I'm not going to use. People and industry are using have shifted to Spark. So we'll learn Spark. Yes, next video we will be learning Apache Spark. Stay tuned. I hope you people have enjoyed it. Thanks.